Unlike location data, we do have a mechanism to configure and test Meraki alert webhooks via the API. Let's dive into that next. We've spent most of our time in this module looking at web pages and various graphical interfaces, and I'm sure you're ready for some Python. Let's begin by exploring the build webhooks.py script. In terms of imports, we see the usual suspects. OS allows us to load the necessary environment variables, JSON allows us to read configuration state information from files, and our helper functions help keep our script clean. We also use time to pace our status checks, which will make sense a bit later. Let's jump into the main function next. Webhooks are network specific, so we must first collect the network ID for a given network name in a given organization. Both the network and org names are passed into main as arguments, ultimately being loaded from environment variables. Then, we load in our webhook data from the add_webhooks.json file. Let's quickly explore that file. This is a list of dictionaries where each dictionary is the HTTP body for a post request that is used to create a new webhook in a given Meraki network. Earlier, we set up webhook.site and postb.in URLs, and this is where we'll define those URLs. I want to briefly credit the creators of each site using their Twitter handles Fred Stead for webhook.site and Andy Chilton for postb.in. Just for fun, I've added their countries of origin as the optional shared secret. Make sure you double check that these URLs are correct for your specific webhook receivers. Next, we iterate over the list of dictionaries so we can access each one. It's a good idea to print a status message indicating that we are about to add a new webhook. I've also added a bit of error checking. Using basic Python string methods, we can test to ensure each URL begins with HTTPS, which is required for all webhooks. You cannot use HTTP anymore, nor any other kind of transport, as far as I know. Rather than crash the program, we can skip those URLs by continuing to the next dictionary in the list. Assuming the URL is using HTTPS, we can issue a post request using the dictionary as the request body to the HTTP server's resource. You can uncomment this debugging line to see what the response data looks like. I'll show a sample in the callout, which reflects back most of the HTTP request body data. The response adds a unique ID in case we want to update or delete a specific server later. I really love that this particular set of API calls allows us to test each webhook without needing real hardware. We can issue a post request to the webhook tests resource and specify the specific URL we want to test. In our case, let's just extract the URL string from the current webhook in the loop and build a small dictionary to represent the JSON body. After starting the webhook test, the initial status returned should be enqueued. Here's a view into what the response structure looks like, and over time, we'll see the status change as the test completes. If the initial status is not enqueued, something went wrong, so raise a value error. For a less destructive response, you could also print an error message and continue to the next server in the list, but I wanted to show some diversity. Next, we have a while loop, which runs as long as the test remains enqueued. Inside the loop, we can optionally dump the contents of this variable. More importantly, we wait 2 seconds in between each status update, then issue a GET request to check the status. We specify the test ID to query for the status of individual tests and update the test HTTP variable. In this way, the while loop will run as long as necessary until the test advances beyond the enqueued state. A successful test will use the status of delivered, and if we don't see that value, raise a value error printing the status that was returned. For example, it might say failed or some other unsuccessful status. Outside of the for loop, we issue a final GET request to collect the list of servers in a given network and dump them to the console as JSON text. This serves as a final confirmation that our webhooks have been configured. As is often the case, we consume the Meraki org name and Meraki netname environment variables and pass them into the main function. This part isn't new, so we won't spend time exploring it. I've already exported the required environment variables to save a little time. Let's run the script using the command shown and see if our new HTTP servers are operating correctly. Okay, it looks like everything worked, so let's scroll up to see all the output. First, the script added and tested the webhook named Fredstead, which was our webhook.site URL. The second iteration of the loop repeated the same steps for Andy Chilton, representing the postb.in URL. Once the loop exited, the script printed a final webhook summary. This included the Meraki network name, followed by a JSON list of all configured webhook servers. This is basically a superset of the data in our add_webhooks.json file and serves as a good indication of success. Let's quickly check our webhook receivers to see if they received any data. To keep things clean, I've cleared all the old location scanning requests from webhook.site. We now see a single post request carrying a JSON body. Let's scroll down to explore. This was a simulated webhook, so there isn't much information here, but it does provide a timestamp and various other bits of data. I imagine that real alerts would populate the alert data dictionary with more actionable information. Let's check postb.in next. I've already refreshed the page, and again, we see a post request. Seems like postb.in converts the JSON data into key value text rather than showing the JSON syntax, but it doesn't matter. The information is comparable to that seen in webhook.site, just displayed differently. Let's quickly check the Meraki dashboard. Let's highlight network-wide first. Then, under Configuration, click Alerts. Let's scroll down to see the entire page. We can specify which specific events should trigger an alert here, and notice at the bottom, we can see all of our URLs. We added these programmatically using the API, but you can also use the dashboard if you like. At the time of this recording, these webhooks are a beta feature, so I suspect there will be minor changes to this feature set over time. Let's wrap up the course in the next clip.